screws. A mechanical device used for converting rotary motion into linear motion and transmitting power. Introduction and applications. Parts of power screw. Screw, knot, a part to hold either the screw or knot in its place. Applications. To raise the load, example screw jack. To obtain accurate motion in machining operation, example lead screw of a lathe. To clamp a workpiece, example height. To load a specimen, example universal testing machines. Advantages: large load carrying capacity, overall dimension is small, resulting in compact constructions. It provides a large mechanical advantage. A load of 15 kilonewton can be raised by applying an effort as a small as 400 newton. It can give highly accurate linear motion. Disadvantage: poor efficiency, sometimes as low as 40%. High friction rates causes rapid wear. Square thread knot is usually made of soft material. In trapezoidal threads, a split type of knot is used to compensate for wear. Applications and efficiency notes. In power transmission, high efficiency is required. Therefore, lead screws and presses are used. For self-locking purposes, screws, clamps, and vices are preferred. Form of threads. These threads are not suitable for power screws due to high friction. Screws with a smaller angle of threads, such as trapezoidal threads, are preferred for power transmissions. Square thread used in screw jack, presses, clamping devices. Efficiency of square threads is higher. No radial pressure or side thrust on the knot, leading to a longer knot life. Difficult to manufacture, usually done on a lathe with a single point tool has a less thickness at the core diameter, which reduces load carrying capacity. Weight is compensated by making the knot of a softer materials. Geometry: height b by 2, thickness b by 2, height b is the pitch. Trapezoidal isometric threads used in lead screws power transmission devices. Less efficiency compared to square threads. High cost radial pressure is at present. Easy to manufacture, a thread milling machine with a multi-point cutting tool is used, resulting in lower cost. More thread thickness at the core diameter ensure higher strength. The axial wear on the surface can be compensated by means of a split type knot geometry. Thread angle is 30-degree, height by 2. Special type of threads, active threads, it used in power transmission screw, lead screws, identical to trapezoidal threads in all respects, but the thread angle is 29 degree instead of 30 degree. Advantage and disadvantage matches those of conventional contrast thread used in ICS combines the advantage of square and trapezoidal threads used where a heavy axial force acts along two axes in one direction only. Advantages: higher efficiency compared to trapezoidal threads manufactured using a thread milling machine stronger than both square and trapezoidal threads. Disadvantages: can transmit power and motion in one direction only. Geometry: threads angle is 45 degree, height equal to 0.75. Buttress plates are ideally suited for connecting tubular components. Example: barrel housing in anti-aircraft guns. Designation screws. Square 13 to 6 SQ, square thread 30 mm nominal diameter, C 6 mm pitch single stud. PR 14 to 7 trapezoidal thread 40 mm nominal diameter, 7 mm pitch single stud. TR 40 into 14 P7 LH double start trapezoidal thread 40 mm nominal diameter, lead 14 mm, pitch 7 mm, LH left hand. In double start thread, nominal diameter is followed by lead number of starts, lead by pitch, which is equal to 14 by 7 equal to 2. Multiple thread screws used where higher traveling speed is required. The traveling speed is twice or multiple times that of a single stat screw. Efficiency of a multi-stat screw is higher due to an increased helix angle alpha. Mechanical advantage is lower compared to a single stat screw. Hence, more efforts is required to raise a given load. Self-locking property may be lost in a multi-thread screws used in high-speed actuator and well terminology. Pitch. The distance measured parallel to the axis of the screw from a point on one thread to the corresponding point on the adjacent thread. Lead. The distance measured parallel to the axis of the screw which the knot will advance in one revolution. For a single thread screw, L is equal to B. Nominal diameter. The largest diameter of the screw. Major diameter. Over diameter. The smallest diameter of the screw thread. Minor diameter. This is equal to D minus B. Mean diameter DM. D plus DC by 2 is equal to D minus 0.5 B. Helix angle or lead angle. The angle made by the helix of the thread with a plane perpendicular to the axis tan alpha L by pi dm. Torque requirement. Torque required to rise or lower a load E is F into dm by 2, where F is the required effort force. Effort required to rise load F is equal to W mu cos alpha plus sin alpha by cos alpha minus mu sin alpha. W mu plus tan alpha by 1 minus tan alpha 0 tan pi plus alpha. Effort required to lower the load. F is equal to W mu cos alpha minus sin alpha by cos alpha plus sin alpha is equal to W mu minus tan alpha by 1 plus tan alpha is equal to W tan pi minus alpha where W load, mean coefficient of friction, pi frictional angle, formula to rise T W into dm by 2 into tan pi plus alpha to lower T W dm by 2 tan pi minus alpha. Self-locking screw. If pi less than alpha torque required to lower the load becomes negative, the condition is known as overbooting or backdragging Yankee screwdrivers. If pi is greater than equal to alpha, that is mu greater than equal to L by pi dm, a positive torque is required to lower the load. This condition is called self-locking. Self-locking is not possible when the coefficient of friction is very low. Self-locking property is lost when the lead is large. Thus, a single thread screw is better than a multiple thread screw for self-locking. Efficiency of square thread screws. Theta. Work output by work input WL by F pi dm tan alpha by tan pi plus alpha. Key characteristics from efficiency versus helix angle graph. Efficiency increases rapidly up to 20 degree helix angles. Efficiency reaches maximum at alpha equal 45 degree minus pi by 2. Efficiency decreases rapidly when the helix angle goes beyond 60 degree. Efficiency decreases as the coefficient of friction increases. Maximum efficiency formula. Eta max is equal to 1 minus sin phi by 1 plus sin phi. Efficiency for a self-locking screw eta less than equal to half minus tan phi by 2. Thus, the efficiency of self-locking screw must always be less than or equal to 50%. Efficiency of trapezoidal or XP threads. In angular threads, the normal force is increased when is equal to double sec theta, where 2 theta is thread angle, 2 theta is equal to 180 for acme and 130 for trapezoidal. To account for this, the actual coefficient of friction is taken as mu sec theta instead of mu. Force to lift F is equal to W mu sec theta plus tan alpha by 1 minus mu sec theta into tan alpha. Force to lower F equal to W mu sec theta minus tan alpha by 1 plus mu sec theta into tan alpha efficiency tan alpha 1 minus mu sec theta into tan alpha by mu sec theta plus tan alpha. Coefficient of friction factors depends upon workmanship, supporting the thread and quality of lubricants, practically independent of load, rubbing velocity, and material choice. Average coefficient of friction for mineral oil is equal to 0.15. When a thrust ball bearing is used at the polar surface, its coefficient of friction drops to about 1 by 10 of a plain sliding surface. Design of screw and knot. Screw materials made of plain carbon steel, often case hardened. Example, lathe lead screws are case hardened using nitriding process. Frame or knot materials usually made of gray cast iron grade FG200 due to excellent castability and high compressive strength. Stress equation for design. Compressive stresses. Sigma C W by pi by 4 DC square. Torsional shear stress tau 60 pi DC cube. Principal shear stress tau max root over of sigma C by 2 the whole square plus tau square. Shear failure of steel thread tau S W pi DC Z, shear failure of knot thread, T tau N, W pi d T Z, bearing stress, bearing pressure, SPW pi before D square minus square to Z, where D is thread thickness at the core diameter and Z is the number of threads engaged within the knot.